In this video for section 2.6, we're going to define composite functions. Composition of functions is basically taking one function and substituting it in for the variable in the other function. So there are two ways that we can write the composite function. We can use these nested parentheses like this, where we have f of g of x. This means that we're replacing x with the entire function g of x. Or we can write it with the circle notation like this. Notice in both notations, the g of x is on the right of the f. That means that the g is the function that is plugged into the f function. Another way of looking at it is in this diagram right here. We have x as our input. We're inputting that into the function g. That gives us g of x. Then we input g of x into the function f, and that gives us f of g of x. So again, the inside function is done first. So we're going to look at example 5 from the textbook. It says, given f of x equals 3x minus 4 and g of x equals x squared minus 2x plus 6, find each of the following. So for f of g of x, what we're going to do is we're going to plug g into f. Or in other words, we're going to replace the x in the f function with the entire g function. So I'm taking this and plugging it in to that x. So what that's going to give me is I'm going to have 3 and then in parentheses x squared minus 2x plus 6. I'm using parentheses because the entire function needs to be multiplied by 3. And then I have a minus 4. Now I need to do some simplifying here. So what I'm going to do first is distribute the 3. So that will be 3x squared minus 6x plus 18. And then I need to combine any like terms. So we have 3x squared minus 6x, and then plus 18 minus 4 gives me plus 14. So this is my answer right here. Part B is plugging f into g, because the f is the function to the right. So I'm going to switch this. Now I'm taking 3x minus 4 and I'm plugging that into the x's in the g function. Now in the g function there are two x's and both of them need to be replaced with 3x minus 4. So that's going to give me 3x minus 4 squared minus 2 times 3x minus 4, and then I have plus 6. So for this one, when I'm dealing with squaring 3x minus 4, I need to remember that I can't just square each term. What I need to do is write that out as 3x minus 4 times 3x minus 4. 3x minus 4 times itself. Then I can distribute this minus 2 here. So that's going to be minus 6x. Negative 2 times negative 4 is plus 8. And then don't forget that plus 6 I had at the end. Now what I need to do with these two sets of parentheses is use FOIL. So that's going to be 9x squared. This is a good review of using FOIL, combining like terms, all that good stuff. Minus 12x. Minus 12x, and then plus 16. And then we have minus 6x. I'm going to add this plus 8 and plus 6 together to get plus 14. And then finally, combining all the like terms all together gives me 9x squared. I don't have any other x squareds. I have minus 12x, and minus 6x. That's a total of minus 30x. Negative 12 plus negative 12 plus negative 6 is negative 30. And then I have plus 16 and plus 14. That's plus 30. So this is my answer for g of f of x. And notice it's not the same as what I got for f of g, so the order does matter in terms of which function you plug into which, because you'll get different answers. Lastly, for part C, I'm asked to find g of f of 1. Now, I have the function g of f of x right here. I just found it. So the easiest way to find this is to just plug 1 into that function for x. So g of f of 1. I'm going to plug 1 in for x. That's going to be 9 times 1 squared minus 30 times 1 plus 30. 9 times 1 squared is 9 times 1, which is 9. 30 times 1 is 30. So we have 9 minus 30 plus 30, which equals 9. So next you should look at checkpoint problem number 5. Do this in your notes, check your answer, and then move on to the homework.